This is a PERT problem. In PERT problems, activity times are triple time estimates. So what we will do is use the 3-time estimates to compute the average time. This is the equation that we will use for computing the average time for each activity. Let me first show you this. If the difference between the optimistic and most likely time and the difference between most likely time and the pessimistic time are the same, then the middle value is going to be, or that most likely value is going to be the activity average duration. So for instance, for activity 2, the times are 3, 6, and 9. So 3, 6, and 9. Each of those pairs are 3 units apart, so it's the same distance. So the duration for this activity is going to be 9, which is the center or the middle value. For activities that rule does not apply to, we must use this equation right here. I have done it for activity 4. You can see that activity 4 has these durations. Those have been used to compute an average time of 5. If the time that you compute as an average is not a whole number, is not an integer, go ahead and at least use 1 or 2 decimals, because if these are months, then the fraction of a month can make a big difference in the delivery time of the project. So activities 8 and 11 also must use that equation. Using that method, I have created all the time estimates, average time estimates, and in this one, I have actually computed the forward and the backward pass. At this point, if you want, stop the video and make sure that you can compute those times on your own. Notice that for activities 10 and 11, since both of those are finishing activities for the project, I have arrows drawn into a finish node, and I use the forward pass. The differences between the 17 and 25, and I have used 25, which then, because finish node is not really an activity, it's a point in time when the project finishes, then if I add 25 and 0, I get 25. Using that 25 to be my latest finish time, then I can work it backwards, and that gives me no slack for activity 11, but 8 units of slack for activity 10. Accordingly, we compute the critical path. Notice that the critical path is activities, or actually I can compute time for critical path, which is comprised of activities 2, 5, 8, and 11. Adding those times up for those activities, I get 6 plus 3 plus 7 plus 9, which gives me 25. So the average time to complete this project is 25, which is indicated with our forward pass calculation. We can also compute the sigma squared for the critical path, or variance. That would be the variance for each activity using the equation here, where we subtract find the range for activity time squared and divide by 36. Notice the variance for, let's say, activity 2 is, notice the times for activity 2 were 3, 6, and 9. So variance for activity 2 is 3, 6, and 9. So 9 minus 3 is 6. 6 squared is 36. So we get 36 out of 36. The same way, we compute 36 out of 36 for activity 2, 4 out of 36 for activity 5, 64 out of 36 for activity 8, and 100 out of 36 for activity 11. That summation is 5.67 weeks squared. So if I take square root of it, the sigma will be, for critical path, the sigma will be square root of 5.67, which gives me 2.38. So essentially, using central limit theorem, if that applies, then we're saying that this project on average takes 25 weeks to complete with a sigma of 2.38 weeks. So we can compute probability that project time will be less than or equal to any number, probability that project time is greater than or equal to any number, probability that project time falls between two different time estimates. We can also compute the probability of a certain service level and what our due date should be to promise such a due date so that we can finish the project by that deadline with a certain service level. So let's compute the probability that project time is going to be less than or equal to 30 weeks for this project. And so I will go ahead and use a fresh, using a fresh page. So we have project time on average is 25, sigma is 2.38 weeks, and we want to know what is the probability that the project will be finished in less than 30 weeks right here. And so for that, I can apply the z distribution, standard normal table. I know that the mean has 0 value for the z, and I need to compute the z value for 30. X minus mu over sigma is what I will use. So 30 minus 25 divided by 2.38 gives me, I need to do that. So that's 5 divided by 2.38 gives me 2.1. So the z value is 2.1 at this point. And what I need to do is use the standard normal table. I have one over here. You can see that when the z value is 2.1, that would be 2.10. It's right over here, and I cannot, since this is a PDF, I cannot highlight it, but you can see that the value is right over here, 0.9821. So I can go to my table, and I know that this value, this probability right here is 0.9821, which is the area to the left of where 0 is 2.1, right here. Okay, another way that we can do this, solve this problem, is by using Excel and the normal distribution. So the probability that x is less than or equal to 30 using the norm.dist function. It asks us what is the x value. In our example, it's 30. What is the mean? 25. What is the standard deviation? Is 2.38. And do I want cumulative probability? And I can put either 1 or I can put true. And if I don't want cumulative, then it would be 0 or false. So we get the same answer, of course. Now another type of problem that we can solve is if I have information about a project and I want to know what is the due date that I must promise so that I will have a 98% service level and only 2% chance that I will miss that delivery date. Because this is the duration of the project, I can use the same 25 and 2.38, but use the table backwards. So in here, I would use, I would scroll to where I see a 0.98, and that would be right about over here. Let me adjust this so you can see it on your screen. So 0.98 is 2.0, is this entry right here, this one, 0.9803, and that would be the z-value of 2.06. So if I go to my paper, I get the z-value is 2.38. I believe that's what it was. 2.06. So 2.06 is my z-value, and this is 0, and I want to know what is this x. So I can use the z-value again, z distribution again. 2.06, we have x minus 25 over 2.38, and you can compute x. Now let's go to, which is 25 plus 2.06 times 2.38. I can solve that using Excel with the norm inverse function. So this would be equals norm inverse, where the probability that I'm looking for is 0.98, mean is 25, and standard deviation is 2.38. And if I do that, I find that it's 29.9 weeks. So that's how you compute probability estimates for a PERT project. Thank you.